Hey everyone, and thanks for joining this session. Today we're going to talk about how AI, and especially agentic AI, are changing the cybersecurity landscape. And more importantly, why the way we test and secure those systems needs to fundamentally evolve, as traditional approaches to testing and defense are no longer enough. I'm Avi, Chief Product and Engineering Officer at Alice. If you're new to Alice, we're an AI security and safety company, working with the large language model providers and enterprises deploying public-facing AI. We help ensure that AI models, applications, agents, and their users are safe and secure, while enabling organizations to get the most out of the technology. So here's a quick overview of what we will cover today. We will start with the AI security challenge, then how agentic AI changes the game, why traditional approaches fall short, what AI red teaming is, and we will close with a key concept that you can take back to your team. But first, let's talk about the challenge of deploying AI to production. The problem is actually pretty simple. AI is trained on the internet. And the internet, as we all know, is full of harmful and adversarial behaviors. And the problem with the AI is that it didn't just learn the behavior, it amplified it. Every technology leap in history expanded both creativity and abuse. AI just did it faster, cheaper, and at great scale. And today, in the agentic era, it doesn't just help create and amplify. It can generate and orchestrate abuse on its own. What this creates is an avalanche of malicious content across every major abuse category: terror, fraud, exploitation, deepfakes, trafficking. We're seeing the same pattern. This is not random. It's driven by adversaries who are often early adopters and know how to exploit systems. And AI now lets them do it faster, better, and at a massive value. And this is exactly the challenge organizations are facing today. While everyone is racing to deploy AI, most are not ready to secure it. According to Accenture, 90% of enterprises lack the capabilities to secure customer-facing AI systems. And this is before we even talk about agentic AI. Most teams are still trying to secure basic GenAI, while the attack surface is already moving ahead. Let's look at a few recent examples. First, we have this notorious Grok example. XAI's LLM became anti-Semitic following a model upgrade. The following day, after a very public backlash, the CEO of X resigned. This is more traditional failure: weak access controls. A recruiting chatbot that was used to collect tens of millions of candidate PII records was exposed, becoming a major liability for the company. And it's not just cybersecurity incidents or PR crises. Sometimes it's simpler, but still damaging mistakes. Here, a Chevrolet chatbot recommends a Tesla. Not a security issue, but definitely a brand problem. No one wants to be the next viral screenshot. And in some cases, it goes far beyond brand risk or liability. When AI systems are public-facing, they can cause real-world harm to real users. We've already seen public cases where unsafe AI interactions were linked to tragic outcomes, including the death of a 14-year-old and the first lawsuit by a US state against an AI company. There are many different types of risks in this space. To make sense of them, we've organized them into simple taxonomy based on frameworks like the OWASP Top 10. At a high level, those risks fall into two categories: security, which is what adversarial users can do to the systems, and safety, which is what the system itself can do to users due to its non-deterministic behavior. Both sides are broad and both are constantly evolving. With so many risks out there, things are going to go wrong. But when something goes wrong, who in your organization is accountable? Some were security issues like data exposure. Some were behavioral risks like unsafe responses that sit within the product. And some were brand and reputational risks, and some were responsible AI department or legal and compliance type of risks. Let's take one example. A model leaks sensitive financial data. Is that a security issue? Yes. Is that a product issue? Also yes. That's how the system behaves. Is that a legal issue? Absolutely, especially if that data is PII. And that's the reality. Those failures don't sit within one team. They sit in the intersection between all of them. Okay, so far we've talked about GenAI, content or data that is wrong, biased or leaked. But the system we're deploying now don't just produce content. They act, they use tools, they make decisions without humans in the loop. That changes everything about how we have to think about securing those systems. The key difference is that GenAI is input-output, mostly with a human supervision. It doesn't take actions, doesn't connect to systems. While Agentic AI acts, uses tools via MCP, can remove human supervision, and can cause cascading failures. The attack surface is fundamentally different. It's no longer just about toxic prompts. It's reasoning manipulation, tool calling exploits, misaligned autonomy, and more. Two examples from the last year, both hitting production systems. First, Microsoft 365 Copilot. A researcher crafted a single email. The next time the recipient asked Copilot to summarize any document, the AI silently pulled their internal files and extracted them to an attacker-controlled server. No click, no alert, no log. The attack exploited the core design of how Copilots reads documents. Similarly, a hidden instruction in a code file that was picked up by GitHub Copilot and auto-approved shell commands on developer machines. There's no exploit here, just hidden instructions followed by an agent that can act. In traditional security, attackers had to get in. With Agentic AI, they already are, because you invited the agent across your trust boundary the moment you deployed it. Here's the picture. Up till recently, the AI threat landscape looked like the bottom side of this slide. Security risks, content risks, legal risks, model behavior risks, familiar territory for the most part. Your teams could map most of it back to their existing playbooks. Now look at the top, the one labeled new. That's what Agentic AI added. Reasoning manipulation, tool calling, memory and communication poisoning, multi-agent attacks, and more. None of those existed as production risks 2 years ago. Today, they are live, and we're seeing them in the wild. And look at the bottom row. Those are behaviors researchers have documented in frontier models this year. The attack surface is growing. It's not that one risk replaces the other, it's in addition. The lethal trifecta for AI agents, coined by cybersecurity researcher Simon Wilson, describes a critical security vulnerability where an AI agent poses 3 capabilities simultaneously. 1 is the access to sensitive or private data. 2 is the exposure to untrusted inputs. And 3 is the ability to tool call or extract data externally. This combination allows attackers to use prompt injection to steal sensitive information or execute malicious actions. Give an agent any 2 of those, and you can manage the risk. Give it all 3, and you've built a confused deputy. Attackers can use the untrusted input to redirect the agent against its sensitive access and have it act on their behalf. So the lethal trifecta is a good heuristic for categorizing risk. But for most real deployments, the answer cannot be, don't combine all 3. The answer has to be, if you're going to combine all 3, you need a way to continuously test how the agent behaves when attackers push on it. For the last 10 minutes or so, we've been talking about the problem. Now I want to spend the rest of our time talking about the solution. As the scale of the problem keeps growing and changing, you cannot rely on the existing practices. 3 control layers: pre-deployment, deployment, and post-deployment. Most organizations today cover 1 out of 3. Usually just runtime guardrails, with no red teaming before and no continuous monitoring after. It's like locking the door without checking the lock. Pre-deployment is the testing before the launch. Does the model behave correctly? Is policy aligned? And what's the risk level per use case? Deployment is real-time protection, guardrails, anomaly detection, human in the loop for edge cases, and more. Post-deployment is what most people forget. Continuous red teaming against emerging threats, version-to-version regression testing, audit trails, and compliance readiness. This is exactly what Alice covers end-to-end, and we're about to show you how. Let's be honest about where most organizations are today. This is the testing stack most enterprise AI security programs rely on right now. Benchmarks, vendor safety attestations, pen testing, human red teams, automated scanning, policy alignment checks. If you're in a security role, you're probably doing most of those. And they are not useless. They catch real issues, but each one has a gap, and the gaps share a pattern. Let me walk you through them. Vendor safety attestation. The model provider tells you that their system is safe, but that's trust. It's not verification. Human red team exercises. It's valuable. It's creative, but they only test the scenarios the tester thought to try. And humans do not scale to the size of these attack surface. Automated scanning, known prompt patterns, and attack signatures, which means by definition that it catches only known threats. Anything new gets through. Benchmark evaluation. Standardized datasets. Useful for baselining, but too generic, not built for your specific use case or threat model. Penetration testing. It's good at finding infrastructure and API vulnerabilities, but it tests systems, not AI behavior. A pen test will not catch a jailbreak, and it will not tell you how the model reasoned under adversarial pressure. Policy alignment. Filter for flagged keywords and content categories. This checks rules, not real behavior. And in AI, the rules and the behavior are different things. While everything is important, pen testing is the most practiced one, the one most organizations consider to be the golden standard. With agentic AI, the problem we're dealing with is fundamentally different. In traditional systems, inputs are structured and limited. In AI systems, every combination of tokens or characters is valid, and even a small change in a character can lead to a completely different behavior. That means that the attack space is effectively infinite. You simply cannot test every possible interaction, especially within real-world constraints of time and resources. So the question becomes, which interactions do you test? And this is where leveraging agentic-based automation changes the game. Instead of trying to map every possibility, you generate, test, and learn. Running far more iterations, adapting based on feedback, and evolving attack strategies over time. That's the shift from static testing to adaptive exploration. This brings us to AI red teaming. AI red teaming is a proactive adversarial testing of AI systems to identify security, safety, and ethical risks before they reach production. Proactive, you're not waiting for the customer to find a failure. Adversarial, you're not running a regression test. You are deliberately trying to break the system, the way a motivated attacker, a careless user, or an unlucky customer would. Running an AI red team assessment is covering a wide range of threats and should help you understand where the system is vulnerable and how to fix it. This is what an AI red teaming program looks like. It starts with mapping the system's attack surface and identifying where behavior can be manipulated. Then, we plan the attack using adversarial intelligence to generate strategies and adversarial prompts. Next is execution, running those attacks across many iterations and variations. Then we evaluate the responses, generate insights, and if a program is good, it continuously improves, retesting, adapting, and evolving both attacks and defenses over time. And the reason this must be continuous is simple. AI systems are non-deterministic. The same input can produce different outputs across runs. So while pen testing finds specific vulnerabilities at a point in time, red teaming exposes systematic weaknesses over time. And this is what an AI-driven red teaming looks like. And more importantly, why it has to be automated. It's a continuous cycle. You generate, you execute, you evaluate, and then improve. An adversarial AI system, an agent that evolves its attacks over time. It generates attacks, run them against targets, score the results, and adapt, refining what works and discarding what doesn't. This agent doesn't just execute, it reasons about how to break the system. So instead of relying on known attacks, it continuously creates new ones, tailored to the specific application it is testing. This isn't a test suite, it's an evolving attacker. Okay, so what did we unpack in this session? The challenge with agentic AI isn't just that it's risky. It's that it combines four forces and they reinforce each other. First, the attack surface expands dramatically. Second, no one in the organization really owns the problem. You can't rely on an R&R to save the day. Third, it keeps changing. And fourth, the system can now act autonomously. And when you combine all four, you get a system that is extremely hard to secure. And if there's just one thing to take away from this, is that we are no longer securing static systems. We are securing behavior, and behavior is not something that you can manually test. The attack surface is growing, the threats are evolving, and the systems are acting on their own, which means security has to change. It has to become continuous, adaptive, and in many cases, autonomous. Because in this new world, it takes AI to break AI. Thanks for joining. If you have any questions, feel free to reach out at alice.io.